So how's it going, everyone? Today we're going to take a look now at the front-end system design, which is a course taught by Evney Ray. This software engineer that has previously worked at JetBrains and now at Meta. And the goal of this course is to see how now UI especially need to understand the fundamental of system design that allows you to then build complex web applications, something that is crucial for companies. So, because here we're going to look now at what are the fundamentals, the core fundamentals, that how the browser works, the DOM API, the Observer API, how to build a virtual list, and then application state pattern, networking pattern, mock system designs to build it, and we're gonna ultimately mock a system design to build them. So this is just a recap of what are the skills the company are looking for, such as the analytic skills, the technical communication. So can I implement your solution based on your explanations? And the other is that engineering best practice. So following the documentation, coding, reading, as well as soft skills like, hey, do you have patience? Are you empathetic with others? And last but not least is the language and computer science specific knowledge, in this case with JavaScript and browsers technologies. On that topic, so this course is laid out in this particular way. And to me, it was quite interesting that Yevni organize this uh, because as we look at the core fundamentals, which most of the time when you take a look at these fundamentals, which a lot of the time are boring stuff, but now they give you is the essential understanding of then how you can come up and build all of the things. We need to have patience here. So anytime we look at the fundamentals, is for us to say, all right, let's go to actually slow down to let it speed up. So uh, after we look at the core fundamental, which is how the browser works, how now the stacking context is, as well as uh, the the stacking content, the rendering context. So how we can now is utilize or use this DOM API as a way to now pretty much like a shovel. This is the DOM API where we can now actually get the elements here just as a refresh and recap of what we can do here. And then we're gonna see is now what are the web API that now certain libraries allow us to achieve with complex UI patterns. So for example, the observer pattern, the mutation observer pattern. And now this is more in co-intense practice. It's a way to how you can build is this virtualization, the application state and network connectivity, which is what are the ways of how you can now manage and store your app level data, followed by the network protocols that we can use. Uh, and also the asset management. So, because this is the front end system design architecture, at least based on EFNIC recommendation, and a lot of people actually are selling you all of these overcomplicated uh, courses and technology and that kind of thing. Is like the whole point of this is to make it simple, bro. That's the entire reason of doing this. It's like make all of these abstractions simple, simplicity. So these applications are organized in backend API and frontend. And frontend, according to Evney and also to myself, is that is the ability that we have now to communicate to our API, fetch some data, or is the ability that we have to communicate with our APIs. How can we store and manage our data, as well as how can we now is implement is certain specific UI interactions by following its specific patterns in. So for example, how now you can show is virtualize elements or long list of elements in a small screen. For example, how you can fit that layout, right? And then how you organize and how you manage all of those assets needed for the browser or for the client aspect. Okay, in our case, with the web technologies such as the CSS, the JavaScript, CSS, HTML, as well as um, the JavaScript, the CSS, the HTML, as well as fonts, for example. So the core fundamentals, or I think I will actually take a.
Hello everyone, communicate with the API and how we manage the
Mhm.
data that we get from the server. So it's about the browser
And I will
rendering
also
side.
take a. That's right. Even though that this will be kind of hard to read, but it will show is now the core structure. Okay. 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 Mm. Cool. Cool. So these core fundamentals and this core extraction here is like, look at now how the HTML treats, or how browser treats the HTML, how the stacking context is connected to the formatting context, which to me is something that I am not quite familiar with, and how such contexts are connected to the GPU. Remember, after all, we are UI specialists. The browser rendering cycle. Mm-hmm. Um, mm-hmm. The browser rendering cycle and the composition layer on how we can use the GPU to optimize rendering. All of these fundamentals, such as now how the browser treats HTMLs and the stacking content is connected to the formatting content, uh, which is again, I'm assuming that this is just adding layers to this. How the stacking context is connected to the formatting context, and how such contexts are connected to the GPU and the browser rendering and the composition layer. Okay. Mm-hmm. In the DOM API, and then we're gonna look at the DOM API, as I mentioned before, Web API for complex UI design pattern. Then now how all of these underlying libraries actually make use of a specific API to allow us to provide is this users interactions or more complex user interaction. That's another reason why we have this specific APIs to solve a specific problems. And look at how can we actually, by using is one of these specific uh, API, for example, like the observer API, how it all makes sense for that. And then how can we, because if you remember the first diagram is like, it's all about is how the front end is all about how you communicate with your applications, how then now you store and manage that data in the most effective and efficient way possible, as well as the asset management, pretty much like or how you can now guarantee some user interactions, especially some complex user interactions. Using now is the observer API as well as a mutation observer. In a more now an example of how can we implement that. and then now the asset management as well. But the idea here is that we're going to see now first is the fundamentals, how the DOM works, what are the web APIs that we are now going to see as a way to allow us to guarantee or to make uh, that allows to build our user interactions in more complex user interactions. How can we now manage the application state? Okay, application state design, followed by the network, uh, and then the part of the application, web application performance, which is now the assets management. And some bonus features, some bonus sections, a way to see how you can now in an interview question, you can actually build all of this. So, um, let's get into this. Let's get into this. So,
So let's start with a very simple concept.
I would like to now is go over to all of these concepts. For example, the initial thing, which is the core concept, core concepts. Okay. The core concept, where here we're gonna see is now the box model, which is something that we are quite familiar. Box model. Okay, so you got is the box model. Then after that is browser formatting and context. Browser formatting, browser formatting context. That's right. Then browser positioning. I am quite familiar to this. Browser positioning. Okay. Reflow. Reflow. Composition layers. Exactly, composition layers and rendering layers. Right? Okay. I mean, it's browser rendering. Okay. It's the browser rendering. So in today's video, we're gonna look at all of this, and we're gonna take what is the value proposition of this. So you're not gonna see what I'm actually doing, because this is me taking note out of that particular course, which is this, right? Of course. And yeah, this will be now the boring part that you are only hear me is babbling, mumbling some weird stuff. But the idea here is that I'm actually watching that content as I take notes out of it.
At first. So every HTML element on a page is actually a box. So, and we can prove this by selecting all the elements on the front-end master's website and apply a green border to that. So, and as you can see, most of the websites is just a set of rectangles composed together. But the thing about that is the box itself has its own anatomy. The box has 4 layers. The first one is the content box. So this is the area where we put our text content. And there is a padding box, the area that surrounds the content box. And there is a border box, the area that surrounds the whole content with the padding. And then there is a margin box. This represents the external space, so outside the element border. And we can play around with the example to see that actually we can compose different layers together, so some of them optional, on the front-end master's website and apply a green border to that. So, and as you can see, most of the websites is just a set of rectangles composed together. But the thing about that is the box itself has its own anatomy. The box has 4 layers.
Border box or content box. You got the border. So you got the border, exactly. So this is now the box anatomy.
The first one is the content box. So this is the area where we put our text content. And there is a padding box, the area that surrounds the content box. And there is a border box, the area that surrounds the whole content with the padding. And then there is a margin box. This represents the external space, so outside the element border. And we can play around with the example to see that actually we can compose different layers together. So some of them optional. So there could be multiple sets of variations that we can build using these layers. So we started with a very simple box model, but the box itself is not that simple. And it has two main properties. The one is the box size, and the second one is the box type. Let's start with the box size. So the box size can have two.
And this is now part of the CDN there. Because this is the box model. No, from MDN docs. Mm-hmm. Wait, what? Is this one? Okay, we're starting with the basics. Yeah. With the box model. Alright, and how now the box model is. Okay, so yeah, we have now types of boxes. Yeah, which is part of the anatomy. We look at the anatomy of the box, which is made of the content, where you put all of your text content, the padding, the content box. Pretty simple, but it's all about boxes. Pretty much in CSS, everything is a box. And this is something. This is because actually no one wants to put time and dedicate time to that boring part, which is our essential, the fundamentals. When you don't open, downloads, you got it, movies, picture, repos, document, dev stuff. Where in the F does this thing store, bro? Where in the F all of these things store? I just wonder where all of this stuff are doing there. Jesus. Okay. That's the question. So where do you store this document? Okay, if I take a look now at the documents, you should be there, my friend. If I tell you that you are in the document, you should be there, bro. Exactly. You should be there. Which is the box anatomy, right? The box anatomy is made of that, pretty much like the myofibril, okay, or like the muscle fiber, which is made of myofibrils, and that kind of thing. This is not the box anatomy, okay? It's made of the content box, the padding box, which is something that I want to bring here. Mm, 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 mm. How CSS is a structure. Okay, this is how the CSS is a structure. How CSS work. Styling and that. And the CSS building blocks. And the CSS building block. So this is now the CSS anatomy, which is made of selectors, cascade specificity and inheritance, cascade layer, the box model, backgrounds and border, handle different text directions, overflowing content, CSS values unit, sizing image, da 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 da. But for our case, we care about is of the box model. Okay. So in CSS, we have several type of boxes that generally fit into block boxes because everything here is a box. Anyway. Box model, box anatomy. But in any case, this is now describing is the box model. The box model anatomy. Then you have the content. Then you have now the padding, the border, and the margin. So far so good because now
Border.
we also
And
have
we started with a very simple sets of variations that we can build using these layers. So we started with a very simple box model, but the box itself is not that simple. And it has two main properties. The one is the box size, and the second one is the box type. Let's start with the box size. So the itself is not that simple.
This is now take a look at this. Alright, which is now the box property when you have the box size and the box type.
Simple. And it has two main properties. The one is the box size, and the second one is the box type. Let's start with the box size.
Okay.
So the box size can have two. Box size itself has two types. So it can be intrinsic. So this means that when we don't apply any rules to the box, the height of the box and the size of the box is determined by its content. And it can also be restricted. So it means that we can apply some fixed size via CSS, or we can also limit the size by the parent. So for instance, if the parent got smaller, the box will adjust its size.
So this is not to recap about the property of the type of boxes, which is in Java. In CSS now everything is a box. So because of that, and you have now property or the anatomy of the box is that it has the content, the padding, the border, and the margin. So now you can easily specify the types of boxes, which is what is the category what is the category of these boxes, and then you have now box type and box size. So whether is these okay, so in the box size you have now intrinsic and restricted. So intrinsic means that the box uses its context to determine the space it occupies. Let's do that again. Intrinsic size, fixed size, limited by parent. Exactly. Okay, box size. The height and width of the box is limited by its parent. Parent percent. Okay. Relative to the parent percent and affected by other child. Okay, very simple and trivial examples, but actually quite relevant. and also silly. It's like box anatomy. So now the box size, okay. What? So now the box size here. The box size. Yeah, the box size, as the name suggests,
content rules to types. So box size, the one is the box size, and the second one is the box type. Let's start with the box size. So the box size can have two. Box size itself has two types. So it can be intrinsic. So this means that when we don't apply any rules to the box, the height of the box and the size of the box is determined by its content.
So when you don't specify it is height, okay, when you don't specify it is size or width and height of the content, the box size will be is now determined by the spaces occupied.
And it can also be restricted. So it means that we can apply some fixed size via CSS, or we can also limit the size by the parent. So for instance, if the parent.
Exactly. So if you don't specify any rules to this box, like height and width, it'll be now intrinsic. This is the content of the box when the size is intrinsic. The content is used to calculate is the size. So for example, if you take a look now, intrinsic, which is unset, make it unimportant, make it important. Okay, when you put now on the intrinsic, on control click, you say this intrinsic size or fixed size. You're gonna see, hey, I'm not going to apply any width. All right. If it's this fixed, I'm going to now is to okay. This is now box size, which is a property of this. Okay. If I don't put any content here, okay, or if I don't specify any the width or the height of the content, it will take the available space as it fits. Okay, as it fits, which is in this case the container, which is all of these flex elements. You're gonna say, hey, we need to take now all the available space. All right. Now that this box content has, in this case, is like this. The font size is 2 root elements. Okay, and you are actually aligning is the container there, which is you saying, hey, this container. This container, okay, intrinsic, okay, box intrinsic here, box fix, which is now with box fix apply, when box, which is this, okay, when this class is applied, you're applying is this, you're not specifying is the width and height, which means that the content will be intrinsic here, which means that exactly you don't specify is the width and height, so you're going to take all of the available space needed, or you're going to now redimension the box size based on its contents. You don't define its width and height. Okay. However, if you do, then it's going to actually fit that content to be there. You can also now put them based on restrictions, as they mentioned. Restricted, this indicates that the box size is governed by a set of rules applied, that it can be explicit width and height set via CSS, or constraints by padding elements on other boxes through mechanisms like flex or grid, layout systems, percentage, which is the parent side, the aspect ratio, property of image, the presence of other children in the DOM. So there are several rules that is applied here in the box size, which is a type of the box model. So as a way to now is calculate is the box size, whether it's based on its content, where I don't specify anything, so the browser will also take the available space for that, or you now put some rules to that, restrict based on its width and height, or constrained by other boxes, constraint made by the flex or grid layout system, percentage, parent side, the aspect ratio property of image, and the presence of other child.
Smaller, the box will adjust its size. And the second property is the box type. So the box itself can be
exactly, and the other property is that the box type
block level, inline level, and anonymous box. So let's go for
okay. But these are rules, bro, which is part of the fundamentals. Let's see it. And the other is a box type.
for each type. So the can be
The anonymous box. The anonymous box. anonymous element. Content editable. Ah, they have that. Okay. But it's because they specify that. Content editable. Oh, no, you don't want the user actually modified. Hell no.
So the block level boxes are rendered like a block, and you may know already most of the text here. But the two main characteristics of the block level box is it always takes 100% of the height, 100% of the width of the parent, and the height of the box is determined by its content size, so intrinsic height. Also, two things about the block level boxes is that the element is rendered from top to bottom, and it also participates in the block's context formatting, BCF. Also, there is an anonymous box, so the browser somehow needs to represent the elements that we don't wrap into the text. That's why the browser automatically wraps this type of elements into the anonymous box, which is the block level box. And apparently, the block level elements have its own mathematics. So if we try to calculate the width of the box, then there will be two cases. The first one is when the box size is set to the content box. So to calculate the final width of the box, we need to sum all the layers that the box has. If we use the border box sizing border box, then the padding and the border already included in the content size, so we don't need to do it manually. If we use the border box sizing border box, then the padding and the border already included in the content size, so we don't need to do it manually in JavaScript, and we just need to sum the margins. So this is a very common pattern that we use in the complex apps when we just set the box sizing border box to every element, so because it simplifies the calculation. The margins. So this is a very common pattern that we use in the complex apps when we just set the box sizing border box to every element, so because it simplifies the calculations.
But he mentioned something here about
participate in the blocks context.
About this. The block type. And the block type. We're not in the block type, which is something that we are familiar with. And all of these elements actually take is the 100% of the pattern width and the intrinsic height, which is the height of the content. And also the element is render. And also the element is render. And also the element is rendered. Okay. The element is rendered from top to bottom and participate in the block context formatting. What in the F is the block context formatting?
Text formatting, BCF. Also, there is an anonymous box. So the browser somehow needs to represent the elements that we don't wrap into the text.
And they call this anonymous box because the browser needs to represent. Okay, representation. This exists because the browser needs to represent is boxes or content, or needs to represent content, not wrap, not wrap into a box, aka into an element.
That's why the browser automatically wraps this type of elements into the anonymous box, which is the block level box. And apparently, the block level elements have its own mathematics. So if we try to calculate the width of the box, then there will be two cases. The first one is when the box size is set to the content box. So we need to calculate the final width of the box. We need to sum all the layers that the box has. If we use the border box sizing,
and remember that after all, the block element needs to calculate, or the box elements use some math to calculate its size, you know. So usually in large apps we use box sizing border box, okay, not the content, because if the content we will need is to actually have to calculate for ourselves is this repetitive task, because with the content we'll need to calculate is the width, we'll need to calculate the width and or height, okay, because with the content we'll need to calculate the width and or height. Yeah, because with the content we'll need to calculate the width and or height yeah, because with the content we'll need to calculate the width and or height of yeah, because with the content we'll need to calculate the width and or height of our element. We'll need to calculate the width and or height of the block by adding or by including the margin, border, padding, and padding. So set to border box like that. We just need to, so we just need is the margin, because now it's included exactly, so we need is the margin. Okay, so set the border box, we just need the margin and the content to calculate the width.
border box, then the padding and the border already included in the content size, so we don't need to do it manually in JavaScript, and we just need to sum the margins. So this is a very common pattern that we use in the complex apps when we just set the box size in border box to every element, so because it simplifies the calculations. So the next type of element is the inline elements. They're completely different from the block level elements because they render as a string. So this means that they are flowing from left to right and from top to bottom. And they also participate in inline formatting context, which is different from the BFC. And they also generate the inline level box. And the inline elements have different mathematics because if you try to apply the width or the height properties to that, they will completely ignore that. And also, they do not react on any vertical margins. And inline paddings also doesn't alter the height of the inline element. So if we look at the example, actually, how it works, then the height of the inline element is determined by its either the intrinsic height or the line height property. everything that goes beyond the line height kind of will be ignored by the browser. So you may open your browser console and see that there is additional height, but because the browser ignores everything that goes beyond the line height line, so it's everything that goes beyond this line will not be participated in any calculations. So we also call it a non-context height.
What is the box anatomy? Box property. Mm-hmm.
So
Exactly. Box property, box size, and box type. Okay, so this is box properties. I want to put this here. Okay, so then you got is the box size. Exactly. So box properties. That's right. So you get now the box model, box properties, like so. And then the box property you have now is the box size and the box type. Box size and box type, right? Like so. Yeah, box size and box type. Absolutely. So you got now the box model, the anatomy of that, of the box anatomy. Okay, the box anatomy, which is something that I'm quite familiar with. It's like I'm not a stranger to this. This is the box anatomy, the box property, box size, uh, box exactly box properties, box types on the box property. What you have now is box size like this, box size and box type, and now how the box size inside of that you got is the you got box size and box type. TN, what the and here you got is box types and box size. You have box size, which is one of the property of this. In this box size here, you have now the intrinsic and restrict, which is the way of how you can how the browser determines the size of this, whether it's by its content if you don't specify anything, or restrict whether by certain rules that you apply to, whether it's width or heights or the flex and grid layouts system, the percentage, the aspect ratio, okay, property on image, mm-hmm, the in the presence of other child of in the presence of other children elements in the DOM tree. This is how now they are calculating as the sizes. Is that whether it's by the other child's elements here or by rules that you put in this box, width and height, as well as the flex or uh, the restriction imposed by uh, layout systems like flex and grid, as well as the percentage, okay, percentage of the parent sites, okay, percentage of the parent sites, and for image is the aspect ratio of the, hey, how I'm going to how I'm going to paint this in image. And this is now the box size, and in the box type, Okay, this is now the box size, and in the box, okay, and in the box type here, where you have now is the block, inline, and anonymous. Okay, which is block, and they follow is a particularly, so the block is now, it is size is determined by the, it takes all the available width of that block. Okay, so the element is rendered in a block for all of these elements that we specify here. Okay, the browser render that, takes all the available space of that. Okay, block level element takes 100% of the percentage of the counter width. The height of the content is equal to the intrinsic size, which is the content size. The element is rendered from top to bottom, and it is participate in a block context formatting. Block context formatting. First time I hear about this shit. And then you got now is the anonymous box, which is pretty straightforward. We know what it does. After all is the browser need to represent those content that are rendered without any element wrapped around them. Okay, which is something that you don't use. Uh, And there, where is the inline elements? Okay. And now, how, for example, is the mathematic of the block elements, where you have, okay. And the mathematic of block elements, the mathematics of block elements as a way to how you can now calculate, okay, how you can now calculate is the size of this box. Okay, that's one of the reasons why we put is border box, box sizing border box like that. And then we have now the inline element, which is another type here, which is inline, and this is now calculated completely different from a block element, because now the key characteristic is that they render as a string, follow from the left to right, from top to bottom. So they render all of these elements from left to right, from top to bottom, and they participate in as inline in formatting context. Oh my god, oh nigga, they generate inline level boxes. Okay, inline formatting context. Holy moly, first time again I hear about this. Inline formatting context. Okay, that's quite interesting here.
So let's start with either the intrinsic height or the line height property. Well, actually, how it works. Then also and also because the from the BFC, and they also generate the inline level box. And the inline elements have different mathematics, because if you try to apply the width or the height properties to that, they will completely ignore that.
And now how the mathematic of inline element, it is all about geometry, bro. You know, it's applying geometry here. It's applying geometry here. God damn it. It's applying geometry here. And this is the mathematics of inline elements. They are completely different to blocks. okay, and does not correspond to the width and height, it completely ignores them, does not react to vertical margin, ignores them, an inline pattern does not alter the height of the inline element. An inline padding does not alter the height of the element. Uh-huh. Mm-hmm.
And also, they do not react on any vertical margins. And inline paddings also doesn't alter the height of the inline element. So if we look at the example, actually, how it works, then the height of the inline element is determined by its either the intrinsic height or the line height property. Everything that goes beyond the line height kind of will be ignored by the browser. So you may open your browser console and see that there is additional height, but because the browser ignores everything that goes beyond the line height line, so it's everything that goes beyond this line will not be participated in any calculations. So we also call it a non-context height.
Mm-hmm.
So we mentioned the term browser formatting context multiple times. So let's understand what.
We mentioned that browser formatting context multiple times, my friend. Yeah, you did, bro. Yeah, you did.
Is that? So we mentioned that you kind of you have an element and some kind of a realm. So when the element falls into this realm, the rules are applied, and the rules can be pretty random. So we can say, okay, if the element falls into the realm, then for instance, the element should take 100% of the parent width, and it also should be rendered from top to bottom. So we basically replicated the block formatting context. But can we slightly complicate this example and say create a formatting context within the formatting context? And apparently we can do that. So we can create a new formatting context, then place the element 2, and we assume that the rules are the same, and the element will take the 100% of the parent container width. But the key difference here is that the inner formatting context is completely isolated from the outer formatting context. Once element enters the realm, it cannot be impacted by any other rules of outer context. We can also complicate this example by creating a new type of formatting context, which we can call inline formatting context. So, and I'm gonna repeat the word formatting context multiple times now. So the element 3 may enter the context, and we can say, okay, when the element enters the inline formatting context, it should be rendered from left to right, and it should take.
There's a reason why a lot of people. There's a lot of people that people who can. Oh shit. There's a lot. There's people who can. People who can sell, teach, and it's because they live in this level of abstraction. They are unable to make meaningful content. They're unable to make abstractions meaningful to others, man. That's what happened. And that's what salespeople or senior developers, senior citizen actually does. Is that they make all of those abstractions, but they also hold a very, very delicate responsibility.
The width of the content it contains. And since the element 3
Oh my god. Yeah, is that there is a reason. There is a reason that people. There is a reason. There is a reason for this quote. People who can sell, teach. As I am looking at the fundamentals of as I'm looking at the core fundamentals of system design, the more I realize about this,
Or stocks, taxes only apply to $500,000 worth of it. So when all the math is done, that nurse is paying about 29% in taxes on her full $70,000 salary. But the investment banker, he's only paying taxes on half of the money he makes from selling assets. That's the capital gains tax advantage. And it's not really fair. So we're going to change that. Starting June 25th, if someone makes up to $250,000 in capital gains, they're still going to pay taxes on only half of that. But for anything they make over $250,000, they're going to pay a little more. They'll pay taxes on 2/3 of that. So the very richest people are going to profit a little less off their assets, only 0.13% of Canadians to be exact. These are people who have an average income of $1.4 million a year and are mostly in their 60s or older. So why am I telling you this if the vast majority of you won't pay $1 more? Well, for two reasons. First, the conversation always seems to be dominated by the richest people in a society. This is a tax policy change that impacts less than 1% of people, but look at how much attention it's getting. And second, you should care about your tax system. This change to the capital gains tax will result in almost $20 billion in new revenue that will go towards the biggest investment in housing in Canadian history, revenue that will create a national school food program, that will make prescription contraception and insulin available for anyone who needs it, that'll build a national dental care program. See, a fair system creates a fair country. And that's what I want. A fair Canada for every generation.
ooh.
Investment banker has a salary of $800,000 a year. When it comes to paying income taxes, they're both paying taxes on all of that income. Now, that nurse may be living a good life, but she's probably not earning enough to be buying and selling assets like properties. But that investment banker, who's making $800,000 a year, probably is. He's putting some of his money in assets, like buying and selling properties or shares in companies. This becomes like a second and sometimes bigger source of income for him. When that investment banker sells those assets, he only pays taxes on 50% of the profits he makes. Now, he's not paying 50% in taxes. It means that if he makes $1 million from selling properties or stocks, taxes only apply to $500,000 worth of it. So when all the math is done, that nurse is paying about 29% in taxes on her full $70,000 salary. But the investment banker, he's only paying taxes on half of the money he makes from selling dollars worth of it. So when all the math is done, that nurse is paying about 29% in taxes on her full $70,000 salary. But the investment banker, he's only paying taxes on half of the money he makes from selling assets. That's the capital gains tax advantage. And it's not really fair. So we're going to change that.
And they say that in the most nice and polite way.
Doesn't span for width. So when the element 4 appears in the context, so they are rendered in a row as a string. So what are the key ideas of the formatting context? The first one is isolation. So elements within the context are shielded from the rules of the external context. So what are the for width? So when the element 4 appears in the context, so they are rendered in a row as a string.
The question is that because we're talking about is the browser context. Browser context. Okay. No, it's the browser formatting. Browser for formatting context. Formatting context explain. Holy moly. Holy moly, bro. Animation backgrounds board. That's one of the reasons I pay for this. I am paying for this because I make myself familiar with this, with the JavaScript and CSS. Oh my god. Everything on the page is part of the formatting context, or an area which has been defined to lay out the content in a way. A block formatting context will lay children out of accordingly to block layout rules. Exactly. So this formatting context belongs to a realm. Belongs to a realm. A flex formatting context will lay the children as a flex item. Each formatting context has specific rules for, and they call this in formatting context as part of the CSS flow layout. These articles introduce the concept of formatting context. Holy s. French toast, of which there are several types, including block formatting context. Of which there are several types, including block formatting context, inline formatting context, and flex formatting context. The basics of how they behave and how you can make use of these behaviors are also introduced. These articles introduce the concept of formatting context. Formatting context. In the CSS realm, this is what it means. Formatting context, in which there are several types of formatting context, including block formatting context, inline formatting context, and flex formatting context. The basics of how they behave and how you can make use these behaviors are also introduced. Everything on a page is part of the formatting context, or an area which has been defined to lay out the content in a particular layout. Hey, this area is now using this particular formatting context in the CSS. So a block formatting context will lay out all children's out of according the block layout rules. A flex formatting context will lay out all of its children out as flex items, etc. Each formatting context has a specific rules about how the job behaves when in that context. Block formatting context. The outer okay, so now this is starting to make a lot. This is flow layout. hmm How do you reach to this F point, bro? Okay. Browser formatting context. So this is the resource, MDM resource. Okay. NDM resource. All right.
So what are the key ideas of the formatting context? The first one is isolation. So elements within the context are shielded from the rules of the external context. It's also the scalability. The CSS spec developers, when they want to introduce a new rule set that apply to elements, they create a new context. And the most known one is like flex or the grid. And it's also the predictability. So when you have a strict set of rules, you always know the position of the element and the placement. So it's time to become a browser and try to render the following HTML page, going line by line and creating the formatting context.
Exactly.
Like the browser does. So if we start with the HTML. So HTML tag, when you initiate the page, always creates a new formatting context. But when we render the body tag, since body doesn't have any special properties assigned to that, so the body just enters the formatting context, but it doesn't create a new one. So same applies to the heading, and same applies to unordered list. But when it comes to the list element, you see that we applied display inline block. So when the element has explicit properties set for the style for the display, this means that it instructs the browser that we need to create
This
a new.
instruct the browser that we need to create is a new formatting context in CSS.
Formatting context. In this case, inline block is the special case of the block formatting context, so there is no inline block formatting context. So we initiated this new formatting context, and every element placed now within that will be rendered as an inline block item.
No, paragraph elements don't inherit display property by default.
And the same applies to the next list item, to the paragraph 3 and paragraph 4. So now we render this section. So when we render this section, we see that there is a display flex applied. This means that the flex formatting context is used. So every item becomes the flex item. But one thing, now we have the span element. And remember we discussed that span creates the inline formatting context. So when everything that is placed inside the span becomes inline content. So we created a new inline formatting context. So this is how browser constructs the different type of contexts and how the elements are rendered.
So can you clarify, is the context set by the HTML tags themselves, or does it have more to do with this CSS? Because like you could overwrite the default.
I don't know why all of the Californian people actually talk like that. It's like I'm actually dragging a lot of my words. It's like I don't know. I really like to drag all of my words. It's like why so fucking lazy when you talk, people? Anyway. Anyway.
Behavior of some of these tags with CSS, right?
So when you initiate the HTML page, so it always sets the blocks formatting context. By default, this is the default behavior. But I think you can override this if you set the style to HTML element. So if you set the flex, then the HTML will have to become the flex formatting context.
Okay, so it's more about the CSS.
Yeah.
And I think that was very, very interesting.
So if we start HTML page or the grid, and it's also.
So the whole point of this is that anytime we are creating now a context, okay, which is a realm of that. Formatting context. Element is not affected by formatting content. Mm-hmm. Mm-hmm. Browser formatting context. Because of this, okay, when the browser starting to render that, is think put in the position, put in the browser positions, like
which we can call inline formatting context. So, and I'm gonna repeat the word formatting context multiple times now too, and we're soon duplicated the block formatting context. But can we, okay, if the element falls into the realm, then, for instance, the element should take 100% of the parent width, and it also should be rendered from top to bottom. So we basically replicated the block formatting context. But can we slightly complicate this example and say create a formatting context within the formatting context? And apparently we can do that. So we can create a new formatting context, then place the element 2, and we assume that the rules are the same, and the element will take the 100% of the parent container width. But the key difference here is that the inner formatting context is completely isolated from the outer formatting context. Once element enters the realm, it cannot be impacted by any other.
so this browser formatting context is the realm in which elements behave according to a set of rules established, or according to a set of rules established by the realm, or aka the browser formatting context established by the realm. Established by the realm, which is block formatting context, inline formatting context, and other formatting contexts. In this guide, we have a look at, in more detail at the block, inline formatting context, and the important subject of creating a block formatting context. In the next guide, we will find out how to normal flow interact with different writing modes. Block formatting context. Okay, prevent margin collapsing. Block formatting context and inline formatting in BFC creation examples. So this div, similar to this, is say, hey, I am a floater box. If I don't pass this, it is like so. I am following is the the browser formatting context, specifically the block formatting context, which is now here as the box. So you say, for example, is display. No. Say display as browser formatting context as a block. All right. which of course it doesn't change anything. If you change flex just a little bit, you change the browser formatting context. If you set that block, it say I'm gonna take is the width. I'm gonna take the 100% of this element, all right, and their height will be the intrinsic values, the content height. Jesus fucking Christ. Oh fuck. And of course, because we're applying float, it's like that's right. Otherwise, is now this element falls into that particularly browser context, browser formatting context, which is the block or block formatting context BFC to do that. For example, if we say now this has flex, look at this. It's a I'm a floated box, but because now it's creating is a because now this is creating a block content. Exactly, you can see, because now it's creating is because now it's creating is when you put this flex, which is creating is formatting context, flex formatting content, you say I'm going to align all of these elements in line, one next to another. All right. Following is this, because P after all actually falls into one of these box type, which is inline box type. Jesus. So if I say is div and I change this as a div, it's supposed to follow is now the block size here. But again, is following is that. Is following is now the rules that apply to the Flex browser formatting context. Okay.
Rules of outer context, and every element that will be rendered as an inline block.
Paragraph element don't inherit display property by default. So you put this one and say something like this. Now this will be is a block, and h1 of course is another block. Now where you are telling to the browser is like, hey, this stacking, this formatting context, which is now the flex rel, this is how it should behave. This if you put this as display block, it's going to actually behave that. Okay, all of these elements will behave in this. Okie dokie. Okie dokie. Okie dokie. Okie dokie. Okie dokie. That's okay. And that makes a lot of sense. So how can we now describe this here? In the rel in which elements behave is the rel in which the elements behave according to a set of rules established by the realm. So we get is we get is so we got several block formatting.
It's also the scalability, the CSS element 2, and we can say element, and what is that? We start with the HTML. So HTML applies to the next list.
It's the context set.
So we got now the block element, the blocks formatting context with 2T, the inline formatting context, as well as other formatting context. such as flex. Mm-hmm. Makes sense.
By the HTML tags themselves, or does it?
Mm-hmm. Browser formatting context. So the key idea of the formatting context, like this. Okay. Mm-hmm. So the key idea of the formatting context is that it is isolated, it's scalable. So for example, we can create a new context, formatting context, for example, like flexbox, grid, flexbox, grid. All right, and it is predictability with a strict set of rules. The placement of elements is predictable. Okay.
Have more to do with this CSS, because like you could overwrite the default behavior of some of these tags with CSS, right?
So when you initiate the HTML page, so it always sets the blocks formatting context. By default, this is the default behavior. But I think you
HTML tag in MDN. But this is from the elements here. If you take now the CSS reference, especially on the okay. Styling text, CSS layout. Responsive design, beginner guide to media queries. Reference guides, image, media query, math, positioning, layout cookbook, media object center, breadcrumb navigation card, tools. But here's a flow layout. Blogging line layout in normal flow. Formatting context explained. Okay, so flow, or in this case, block element, block level content, block formatting content, and that kind of thing. Block level content, blog in CSS, visual formatting models. Oh, but this is when they started to explain now the box model. You got the blocks and inline boxes. To read more about the value of display and how boxes is work in block and inline layout, take a look at the block and inline layout. And what is a CSX box model, which is the anatomy of this? the standard CSS box model. The actual space taking up by the box will be 410 px, like this. It's alternative box model, exactly, playing with box model, but using display inline block. Test your skills. And then the summary of this: blocks and inline boxes. HTML, CSS. Okay, but this is going too much into the rabbit hole. We just only want is to actually is
You can override this if you set the style to the
understand
HTML
all of
element.
this basic
So if you set the flex, then the HTML will have to become the flex formatting. Okay, so now we have the browser positioning system. So in the web, we have a term, normal flow. So it's basically when the elements are rendered in a natural order. So for instance, in the Altier languages, they rendered from top to bottom, from left to right. From RTL languages, they rendered from right to left. And if we have a term, normal flow, does it mean that we can remove elements from the normal flow? And apparently we can. So there is a special property called position that allows us to override how the browser positions the element. And the most used one is the static relative or absolute. So we'll start with the static. So the static is basically applied by default. When you build your layout, the browser applies the static position to every element. And as you can see, if we render this HTML, we'll see that everything is rendered from top to bottom, from left to right. The position relative has a few interesting characteristics. So the element in the center is positioned relatively. So the key difference is the browser renders the element that is positioned relative the same as the normal flow, but the final position is determined by the top, right, bottom, and left properties in CSS. So we can move our element, and you can see when we move that, the change to the position doesn't impact other elements. So somehow we can adjust the position of the element without impacting other elements. And this is because the element is removed from normal flow. And when the element is removed from normal flow, it doesn't impact any other elements. And there is also one important term that we're going to look after a few slides is a stacking context. So when we apply position relative, we create a new stacking context, some kind of new realm where we put all our elements. And these elements now are completely isolated from everything that is within the normal flow. So before we discuss the position absolute, I think it's important to understand what is the containing block. So the containing block is kind of a reference point for the element, how it calculates its position on the screen. So for instance, for HTML, the containing block will be the browser viewport. When you open the page, your browser window. So this is the default viewport for HTML. But there are rules when we can create the containing blocks. So for instance, if you apply the relative position to the div tag, you will see that because the relative position is applied, it becomes the containing block. So now the div is the containing block of the paragraph. So the same, there is one more rule, which is if we set the position relative to the element, the closest containing block of this element will be the closest ancestor. So this means that the body as a closest ancestor becomes the containing block of the div tag. And let's discuss the position absolute now. So the position absolute behaves completely different from the relative positioning. So the element is removed from the normal flow. So if we apply the position relative or absolute to the paragraph, So now we create a new stacking context. So as you can see, every modification that we potentially could do to this element will be isolated from the default stacking context. And also, the final position is always determined by the top, right, bottom, and the left properties. And absolute position item use its containing block to calculate its position. So by default, this element will be rendered at the left topmost corner of the element. And then we can adjust its position using the properties here. Let's try to render a few absolute items. So for instance, we have the following HTML. And right now we rendered the body, section, and a div. Now we have two absolute position boxes. So let's render it one by one. So when we render the box 1, so we created a new stacking context because position absolute is assigned. So when we render the second box, then we created a new stacking context. So now box 1 and box 2 are rendered in the separate realms. And also you can see that because it's a stacking context, the box 2 is rendered on the top of the box 1 because the layering works as like a stack by default, unless you apply the z-index property. So what is the key summary? Why it's important to understand the relative and absolute positioning? The benefit of the relative and absolute positioning lies in their ability to remove items from the normal flow. So if we use this positioning wise, we can achieve the isolation. So every modification to the element will be completely isolated. So it means that we can optimize the DOM performance. And it's also, we can minimize potential reflow. And we're going to discuss reflow just in a few slides. And to prove the point that there is a kind of z-axis when we render the element. So when we just build a template with HTML, we usually utilize x and y axis. But there is another axis, which is z-axis, which is used when we apply some 3D transformation, absolute positioning. So basically when we work with the stacking context. And we will see later in a few slides how stacking context is connected to GPU and how the browser utilizes the layers. So right now, all we need to know that the stacking context provides us with a layering system and isolated realms of the elements. Okay, so to prove the point, we can render 3 boxes and kind of and change the perspective how we view at the viewport, and then apply the translate z and move the elements kind of on top of each other. So you see that they kind of stack on each other.
It's because all of this browser render context or browser formatting context is because all of this formatting context here, when you indicate an element that you want to break the normal flow of that, all right, you're putting that in a different context stack, which is you're putting is like in a different layout position. By doing so, when you're breaking that, you're actually putting it on top of that. It's like putting this it's like putting this slice. It's like putting a slice of okay. It's like putting a slice of pepperoni on top of your pizza. All of this, especially when you're defining is a different especially when you're defining is a different context. Especially when you're defining is especially when you're defining is a position, a different position, it creates a different context here.
Does it mean that static, relative, or absolute? So we'll start with the static.
So it creates a different context. It's going to create a different slice from that. That's quite interesting, bro.
Okay, so the next topic is the reflow. So what is the reflow? When you read your HTML and CSS, so the browser compiles two trees. One is the DOM, which is basically the object representation of your HTML. And the second one is CSOM, which is the tree of all CSS rules that apply to some HTML elements. And the final render tree is built using both of these trees, so basically merging them. Then there is a process called reflow. The reflow happens when some JavaScript tries to modify the DOM tree or the styles. So for instance, it could be you have the load more button, and then you render more cards on your list. Or it's also could be when you're rendering your React app. So you first load your index.html, then you provide a container where React should work, and it do the modification to the DOM via DOM API. So the reflow process is multi-step pipeline. First, it kicks off the. It's usually kicked off by JavaScript. Then, when we apply the DOM modification, the browser needs to recalculate the DOM and CSOM subtree. So it compiles all your style selectors, then rebuilds the DOM and CSOM tree. Then, once it's ready, the browser needs to recalculate the positions and the HTML properties. So it's a layout phase. So, and the style and layout phase are very CPU bound. This means that if we trigger reflow too much, we can block the render thread. Once everything is ready, and now we need to draw the bitmap on the screen, the GPU is used, which is the paint phase. So the paint phase is basically drawing the pixels on your monitor. Mm-hmm. So it involves the GPU, and it's separated from the CPU. So this means that it doesn't block the rendering thread, and it's pretty fast because GPU is very good at drawing pixels on the screen. And then there is a composite phase. The composite phase is the last phase when you have multiple layers on your screen. So the composite phase just arrange them in the right order to make sure that everything is displayed correctly. And to prove that we can optimize this pipeline, actually, first let's look at the example of the reflow. So this is the Wikipedia page that we can use. And as you can see, this is how the browser renders the page into a reflow. So first it goes from top to bottom, and then you will see that there are some styles loaded, and the browser needs to do the full reflow for the page. You see we again go from top to bottom, just adjusting the styles on the elements.
God damn it.
So let's have a quick example of the non-optimized pipeline where we utilize the style, layout, paint, and composite phase, and optimized pipeline. So we need to open the code sandbox example. So right now we're rendering 2,000 rectangles on the screen, and the idea is right now the page is using optimized pipeline, so we mostly utilize the GPU, and as you can see, there is no lag on the screen, so we are getting our 60 FPS, and we can measure the performance by going to the performance tab, and now we can try to see how much CPU is loaded. So we can run the quick snapshot, and that should be enough. So if we look at the CPU here, so we utilize 0% of CPU. So it basically, it's a flat line. But we can switch this to the non-optimized pipeline. So let's try to run the snapshot now. And you see the buffer is filled in 3 seconds. See, now the CPU is loaded. And the thing is, this Mac is 16 cores, but you don't have the 16 cores M2 Max on every device. And if we throttle the CPU here, you will see that CPU will work hard just to move this 2,000 rectangles. The difference in the pipeline sometimes, and if buffer is we can switch this to the non-optimized pipeline.
Okay.
So let's try to run the snapshot now. And you see the buffer is filled in 3 seconds. See, now the CPU is loaded. And the thing is, this Mac is 16 cores, but you don't have the 16 cores M2 Max on every device. And if we throttle the CPU here, you will see that CPU will work hard just to move this 2,000 rectangles. The difference in the pipeline, sometimes the code difference is very small. So if we look how everything is built, is just 2 lines. If we apply the margin top property in animation, then what the browser does, it needs to recalculate the position of every element, like of all 2,000 rectangles, to render the frame. While we apply the translate Y function, it only moves the pixels. It basically draws, it uses only the GPU just to draw a new pixel set, because the CSS transformation, they do not utilize CPU.
Okay, holy moly, bro.
Now let's understand how the browsers utilize the GPU. So the old browsers used only the CPU to render the page, but the new browsers use CPU and GPU together in parallel to optimize the rendering. And let's now understand how the GPU is used by the browser. So we render 4 boxes here. Each box is absolutely positioned and slightly moved on top of each other. So And here is our HTML tree. So apparently, for the browser to optimize the HTML for the GPU rendering, it needs to have some kind of rendering tree representation, which is GPU aware. So the browser constructs the render object tree. So where for each DOM element, we create a new render object. And as you can see, it's just one-to-one copy, but they have completely different properties. That the DOM element contains all the information about HTML, all its properties, while the render objects knows how to draw this element on the bitmap using the graphical context, which is passed from the top. And as you can see, so the GPU is good at rendering many things, but if we imagine that every render object is responsible for drawing itself on the page, it doesn't look like a very optimized way to use the GPU. So that's why there is additional concept called render layer. So the render layer is constructed when we actually use the position relative or absolute. So when we move elements to the stacking context, so basically create a new layer. Also, it's constructed when we for the root elements, so we always need to have a root layer where we render the things. And when we utilize some accelerated context like canvas or CSS filters. And let's try to construct a render layer. So if we take the first HTML render object, we'll see that because it's a root element, the first root render layer will be constructed. But then we have the body and the main tab. Because the body and the main doesn't have any special properties, these rendering objects will be assigned to the root render layer. And now let's move on to this for diffs element. So because each of this div element is positioned absolutely, this means that we need to promote these objects to separate render layers. So that's why we created a new for rendering layers. And also these rendering layers will be applied to the root render layer. So each render layer kind of has a children property, and it stores the render layer as a linked list in the stack order. So the last layer will be the first rendered. We may have like hundreds of render layers. It's still not efficient to use the GPU for hundreds of objects. So, and remember, the GPU is good at rendering many things. So how does the browser go about that? Apparently, there is an additional layer called graphic layer, which is constructed when we use some 3D acceleration. So it can be perspective change, or we use some video element where we need decoding from the GPU. So, and if we try to construct a graphic layer for that, so first we'll start with a root render layer. Because it's created by HTML element, we initiate the first graphic layer. We need to have at least one when we load the page. So for the rest of the rendering layers, because they do not utilize any 3D acceleration, we don't actually need additional rendering layer. That's why all this rendering layer will be applied to the one graphic layer. So now we have our graphic layer that has the graphic context and knows how to draw the rendering layer. And now we have the full cycle of how browser renders things. But let's run a quick demo to see how this actually works. So if we open the following code pen and open the debug mode, now we need to transition to the layers tab. So we will see that a single graphic layer right now is created, and it utilizes 8.7 megabytes of the GPU memory. So what the key thing about graphic layers, we can utilize the graphic layers to optimize certain part of the app. So for instance, you could have the widget that relies on very advanced animations. Then you can say, hey browser, I want this on a separate graphic layer, so you can optimize this widget and I can see my snappy animation 120 FPS. But the thing about the graphic layer is it utilizes the CPU and the GPU RAM. So every time we create a new graphic layer, we actually take a hit on the browser resources. And it's very easy to prove by applying the styles to the box. And let's promote each box to a separate graphic layer. So let's say we can apply 3D transformation. And if we go back to the layers tab, we'll see now that we have 5 graphic layers in total. And the first one still utilizes 8.7 megabytes, but each newly created one utilizes more than half megabyte of the virtual memory. And the problem of that is, imagine you have a list with hundreds of elements inside, and you decided to promote these elements to the graphic layer. This means that you immediately consume around maybe 100 megabytes of the GPU memory. And GPU memory is not just used for the browser and rendering the page, it's used for the system. And your application may become unresponsive because the system will have to utilize the additional swap cache, and when we use the swap, then we get the unresponsiveness of the app. So the summary for the graphic layers, it's a very powerful thing to utilize when you build your complex apps, but you need to make sure that you utilize it right, because it uses the VRAM and also the CPU. So instead of optimizing the app, you may end up de-optimizing your application.
Is there any good rule of thumb for avoiding CPU-bound operations in CSS?
There is a website called What Triggers What Triggers CSS or something. So you can actually see what is the pipeline will be triggered by changing the certain CSS properties. You just need to make sure. So it's always the rule of thumb, try and minimize any reflow. Always try to change the properties that do not trigger the full pipeline. So this is the rule of thumb. There is no good reason to just always use the full pipeline, because it always affects the application performance.
Yeah, I found it. It's csstriggers.com.
Yeah.
And then Lucas says 8.7 megabits sounds like a lot to me. Am I wrong? And what could be a good, healthy number?
No, actually, it's a relatively small number. Usually, websites utilize around 100 megabytes of the virtual memory. So, and it doesn't grow linear. So the more, because we need to initialize the initial context, we always pay the price of this initial utilization. So it will be kind of the constant. But if you try to promote too many layers, then you may have an issue later.
Yeah, I think there's a tweet about front-end masters that they were watching a course and taking notes and doing all these things, on our website, and it was taking like 1/10 the resources as another just marketing page that was just trying to show a couple like animations or whatever, and how like absurd it is how people can like abuse the CSS engine or just JavaScript in general, having so much on the page and things shifting around, like how much that bloats up the browser.
So it may impact the performance significantly. So for instance, if you have list of items and each item will be promoted to the graphic layer, then I think it will take around 200 megabytes of memory easily. And we need to remember that the web now is consumed mostly by mobile devices. And when we have the mobile device, we don't have such benefit. We don't have RTX 4090 everywhere. And that's why we need to be aware of the layers that we're utilizing in our app. Just make sure that you use them wisely. So, for instance, if you have high interactivity widget that using some nice animation, you can promote this to a separate layer. But if you have a static page and you just promote every element to the graphic layer, then it's where we can get an issue.
I have heard that CSS transforms are good optimizations over reflows. So how do we correlate this now, given transforms take a hit on the GPU memory?
So it's always better to utilize GPU than CPU, because when you utilize CPU, you block the rendering thread, and you will see that your responsiveness drops. So if you need to choose what to utilize, always utilize GPU. You need to you need to put a lot of effort to make sure that your app is unresponsive because of GPU.
Okay. You need to be very careless about your GPU performance issue. Very careless to actually make a performance hit. Okay, so box sizes, box shadow. Once this layout operation is completed, any damaged pixel will be painted, and the paint must be composite. CSS trigger list, what kind of change you can make? CSS trigger list. Okay.
But it's very easy to make a few mistakes and then get a frame drop.
Okay, this is very interesting because this is not the foundations of what's coming next. This is now the foundation of what's coming next. So that'll be all for this video. Take care. Bye bye.